Hi everyone. So guys, in this video, we'll be learning about how we can implement RAG application with the help of Vertex AI. So as of now, we saw how we can use model garden. That means how we can access different kinds of model. On top of that, how we can perform the inference. But let's say if you have some custom data, and with the help of that custom data, you want to create a knowledge base and you want to connect your large language model there. Okay, and you want to perform the query operation on top of it. So how we can perform it. And this is called actually RAG. I think I already explained, okay, in my previous video. So if you're not sure about the RAG, guys, first of all, check those video. Then you will be able to understand, okay, what I'm trying to implement here. So that means, let's say here I'll be using my custom data. And with that custom data, what I will do, I will create a knowledge base. Okay. And I'll just try to connect my large language model there. Then I'll be performing the query operation on top of my data. The data actually I have uploaded. This is the thing we'll be implementing. And here technology wise actually we'll be using the Vertex AI, entire Vertex AI platform. That means here everything will be using Google Cloud services. Okay, we are not going to use any third-party services. That means to store our data we'll be using Google Cloud bucket, and to store our embedding we'll be using vector store. Okay, vector store service from the Vertex AI. This is one of the vector database they have created. Okay, this is called actually vector store. So we'll be using all the Google Cloud service only, not any other service. Okay, in this video. So for these guys, you can see I prepared one notebook in the Collab Enterprise. So first of all, try to connect the notebook. After that, you can check with the help of OK command. And if it is giving the OK message, that means notebook is running. Then the first thing what you have to do, you have to install. These are the library. As I have told you, we'll be using some custom data. I'm going to use PDF document. That's why I'm installing this PyPDF2. Okay, this library. Then Google Cloud AI platform, because if I want to use the Vertex AI, I need to install this package. Then I already told you we'll be using custom data. That means custom document. And to store this custom document, I'll be using Google Cloud bucket. I think you know Google Cloud also provides bucket service. Let me show you. So if you just open Google Cloud and search for bucket, so this is the bucket. So here you can create different bucket, and inside a bucket you can store the data. See, I already created one bucket called start content 2024. Inside that I'm having one documents. I'll tell you how to upload this document here. As of now, just try to consider we'll be using this bucket services to store my content. Okay, and no need to create manually, it will automatically create. I've already written the code for it. So these are the packages you have to install. For me, I already installed everything, so I'm not going to install again. Now see, you have to import. These are the library right now. So here I'm importing storage from google.cloud, because I told you we'll be using bucket, and to install bucket I need this actually function. Then I'm also importing text embedding model from the Vertex AI language model, because here we have to perform the embedding generation, and to generate the embedding I need some embedding model, and here I'm going to use Google embedding model. Okay, from the Vertex AI, from the model garden. That's why I have imported this text embedding model function. Then I also imported AI platform PyPDF, and these are the library I also imported here. And here I'm using UIID. Okay, why I'm using UIID? Let me tell you. See, there is a reason actually I'm using UIID. See, if you're using Vertex AI, this RAG would be slightly different. Okay, slightly different. That means, let's say whatever documents you will be publishing. Let's say I will be publishing one statistics PDF I'm having. Let me show you the statistics PDF. So guys, as you can see, this is the statistics PDF actually I'm having. So this particular data actually I'll be using as my custom data. Now what will happen? First of all, I have to extract the documents from the PDF, yes or no. So after extracting, what I will get different documents. I think you know, I'll get different documents. That means doc1, okay, then doc2, and so on. Now what will happen? This document I have to convert to embeddings as well. That means it would be converted to embeddings. So let's say you will get some vector here. Let's say 0.29, 0.55, 0.88, and so on. Let's say this is the vector representation of this doc1 and doc2, and so on. Let's say I'll just create some dummy vector here. Now here what I want to do, with the help of this UIID, I want to assign some unique ID. Let's say the document one it has extracted, I will assign one unique ID. Let's say this is the unique ID. Let's say 1210. Let's say this is the unique ID. Okay, it has assigned to the doc1. Then in the doc2 it will assign another unique ID. Let's say 1211. Okay, now what will happen? This unique ID also would be assigned in the vector, because this vector is representing this documentation, yes or no. Okay, that's why this ID would be there, 1210. Then this ID would be also there, because this vector is representing this document. So 1211. Now what will happen? Let's say whenever you will perform the similarity search operation, that time what happens actually, it will return the relevant answer, yes or no. I think you know, whenever you implement any kinds of RAG, whenever you perform similarity operation, it will give you some relevant answer. Okay, relevant answer you will get. Okay, And from where you will get the relevant answer? From the documents only you will get the relevant answer, the documents you are having. Okay, now let's say it will give you this relevant answer. Let's say doc1. Whenever it will give you doc1 relevant answer, that means it will return the vector, because your model will only return the numbers, not the text. Okay, and this particular number will map where? In this document. That means this document is representing this vector. That means whenever your model is generating this vector, that means it will map these documents, that means the text. Okay, how? With the help of this UIID. Okay, with the help of this UIID. So it will look for where this UIID is present. That documents actually it will show you as a relevant answer. Okay, now I think it is clear why I'm using this UIID to give to assign actually unique ID in front of my documents and in front of my vector embeddings. Okay, now I think it is clear. Now let me clear my board. Now the next thing what you have to do, guys, you have to initialize some of the variable. Now see, if you are doing this project from the Google Colab, first of all you have to authenticate with your G Cloud. And how to authenticate, I already shared you two code. I think you remember two configuration code I shared with you in my Vertex AI demo session. So you can refer the notebook and you can first of all authenticate with your Google Cloud. Okay, until you are not doing the authentication, it won't be working. I'm running from my Colab Enterprise, that's why I don't need to do the authentication. So if you're running from the Colab, Google Colab, so you have to activate this line actually, project. So you have to give the project ID here. How to collect the project ID? This is the project ID. Got it? So here I'm running from the Colab Enterprise, so I don't need this variable. I'll just try to comment it out. So here what I need the location, and this is my location. Then PDF path. So where you have to upload the PDF. So in the files actually you have to upload the PDF. Let me show you. So here you can right click and upload and try to select the PDF. Whatever PDF you are having, just try to open it here. It will automatically upload here. See, for me, I've already uploaded. And these two files would be generated as of now. See, I already executed this project. Okay, that's why all the artifacts you can see. Okay, but for you, it would be empty initially. So this two file would be created. How it will be created, I'll tell you. As of now, just try to consider we have uploaded the statistics.pdf file. Got it? Then you have to give the bucket name. So you can give any kinds of bucket name and make sure this bucket name should be unique. So this bucket would be created automatically in the bucket section. See, it is already created for me. Again, this would be created automatically. You don't need to create it manually. Then here you have to give embed file path. What is embed file path? Because see, I already told you, first of all, we have to extract the documents from my PDF. Then what we have to do, we have to generate the embedding as well with respect to the documents. And these documents and this embedding, I'm going to save in a JSON file. Okay, that's why I'm just creating some JSON file. You can see these two JSON file I'm creating. Okay, starts embedding .json and start sentence.json. Inside sentence.json, it will store all the documents, that means the English text, and inside embedding, it will store all the your embedding. Okay, embedding of the sentence. That means whatever, let's say, documents you are having. That means whatever documents you have, okay, with respect to that, it will store the embeddings as well. Okay, with the unique ID. So that is the thing. Then you have to give the index name. Index name means, let's say here we'll be using vector search, and inside vector search, we just create an index. The way actually we used to create the Pinecone index, I think remember, we create an index here. So this is the index name. It will automatically create that index. Now here I've written a function. This function will extract the sentence from the PDF. So it will take the PDF path and it will give you the sentences. That means all the documents it will give you. Then I have written some of the helper function, guys. You can see generate text embedding. That means this function will generate the text embedding. It will take the sentence and it will generate a text embedding with the help of text embedding model. You can see I'm using text embedding gecko model. So this is the model, guys, text embedding gecko 001. So this model is available in the model garden in Vertex AI. Got it? Then I have written another function, generate and save embedding. That means this function will actually add the unique ID in front of your sentence. That means documents, and in front of your embeddings. That means vector embeddings. Okay. That means it will generate this both file. Okay, and it will save as a JSON file. You can see here I'm doing it. I'm first of all actually creating my embedding. Okay, and I'm adding the unique ID. I'm also creating the sentence. I'm adding the unique ID. Then I'm saving in a JSON file. Okay, this is the thing actually we are doing. That means this function is responsible for creating these two files, and it will store your sentences, and it will store your documents as well as the embedding with the unique ID. Okay, that's it. Then there is another function I created called upload file. That means after let's say generating this file, I have to upload this start sentence.json in the bucket. And how I will push to the bucket, we will be using this function upload file. I can see if you go to the bucket section, so this file is already present. Okay, so if you want to push any kinds of file, you can use this function. That means we created some helper function. This helper function will help me to do certain operation. This is the thing. Now here another function I have written called create vector index. So this function will create the vector index in the vector source. Okay, in the vector source vector database. and each of the dimension would be 784. I think you remember previously we used sentence transformer actually embedding model, and we used to create I think 384 vector representation. I think you remember, right? But if you're using this text gecko model from the model guardian, your vector dimension would be 780. 768. This is the dimension, and you can see with the help of AI platform actually library we are creating the index. So this function will automatically create the index for you. Got it? Then after that I'm calling these are the function. You can see first of all I'm calling generate and save the vector. I'm giving my PDF path, sentence file path, as well as the embedding file path. Then I'm also uploading this file to my bucket. That means if I execute this line, what will happen? It will create this two file. First of all, let me open it. So this is my sentence. That means this is my document, and you can see first of all it will show you the unique ID. Then it will show you the sentence. Okay, that means this is the document it has extracted from the PDF. With respect to that, it has also saved the embeddings as well. Let me show you. So this is the embedding, and here you'll see the unique ID. That means the same ID, and now this is the embedding representation. Okay, I hope now it is clear. Now, so once it is executed, then upload file will execute, and it will upload this sentence.json to my bucket. Now if I show you, see bucket would be created, and inside bucket actually you will see this start sentence.json would be present. Okay, because later on, whenever I'll perform the, let's say, similarity search operation, I need that file. I need to download that file. With that, I'll do the search operation. Okay, similarity search operation. That is the thing. Now, the next thing, what we'll be doing, we'll be creating the vector index. That means we'll be creating the index, and inside index actually will be storing all of my vector. Okay, so here you can see I'm giving the bucket name. That means from the bucket name, it will load this file. Okay, it will load this file. That means the sentence file. So sentence file it will load. Then it will also take the index name. And with the help of actually that embedding model, it will generate the embeddings of that documents. The documents actually we are having, and it will store to the vector database. That means inside my vector source. Now, if I execute this line, okay, if I execute this line, it will take some time. That means it will process all the data and it will store to the vector embedding. After that, if you open it up, let me show you. So if you open it up, so you'll see that it will create an index. The name actually you have given start index. Okay. Now you can see both places you are getting this green tick icon. That means everything is executed successfully. If you are getting any red icon, it's not completed. Okay, that means there are some issue. Now if I click on the deployed index, you'll see one ID here. So we need this ID later on. So guys, you can see this is the ID. The last number you can see, this is the ID. So we need this ID later on. Okay, see this is the ID. This ID actually we need later on. So now let's get back to my Colab. Now again, just import some of the necessary library. Then again, set these are the actually variable like your location, sentence file path, and index name. That means the same index name. Okay, same index name you have to give. Start index. Okay, that's it. Then just load the model, large language model here. So here I'm using Gemini Pro. You can also load any other model. Then just try to load the index. That means index endpoint you have to load. And to load the index endpoint, you just need to give this ID. And how you'll get the ID, guys? I already told you. So this is the ID. Just try to copy this ID and just try to paste it here. Now if you execute, it will load the index ID. Got it? That means this is going to be your knowledge base right now. And this is going to be your model. Now again, I have written some of the helper function generate text embedding. That means whatever user will give the prompt. Now let's say I have given one prompt. This prompt should be also converted to the embedding. Okay, then this function will help me to do that. Then I've written another function generate context and load file. That means it will load that documents file and it will generate the context. Okay, that means if you are performing similarity search operation, it will give you some rank results, and how it will give the rank results with the help of these two function, it will give the rank results. Now here I've loaded the file. Then you can see. Then this is my query. Let's say what is correlation. First of all, I'm generating the query embedding with the help of that embedding model. And if you want to see the query embedding, see this is the vector representation, guys. This is the entire query embedding. Now let me comment it. Now this query embedding I will pass to my vector source. Okay, now you can see find neighbor. It will give me 10 ranked results. Okay, 10 ranked results actually it will give me. Then this response actually I'm giving to my model. Okay, this is the code snippet. My model will try to analyze this response, even the query I have given. Based on that, it will give me one response. Now if I execute, see, if I execute this last line of code, see here you will get the response. Correlation is a statistical measure that indicates see blah blah. I'm getting the output, and here you can also give the prompt based on the context delimited in the brackets, answer the query. Okay, that's how you can give any kinds of prompt, and that's how actually we can build retrieval augmented generation kinds of application. Okay, with the help of Vertex AI platform. And all these steps, guys, I have mentioned here. So if you are implementing any kinds of RAG based actually application, you can follow the same step. Okay, even you can also perform in your local machine. That means I told you how we can connect our local machine. That means how we can connect our VS Code. So with the help of VS Code also, you can create this kinds of RAG application, and you can create a user interface. Let's say you want to create a Flask interface, you want to create a Streamlit interface, you can also create. So this task actually I want to assign you. Just try to create one user interface. So you have to use the same logic, only you just need to integrate one user interface. That is the idea. Okay, I hope it is clear. Now see, once it is done, now if you want to terminate all the instance, what you can do? So first of all, just try to delete this. So first of all, just try to delete the bucket. To delete the bucket, just try to select the bucket, and there is a delete button you will see. Just try to click on delete, and delete confirmation you have to give. So it will delete the bucket. Then you also need to delete the index. So to delete the index, just go to the index, vector search. So first of all, you have to do the yarn deploy. Then you can delete it right now, I think. Now there is a delete button. Just try to click on delete. So it would be deleted. Okay. So that's how you can remove all the instance you will be creating. Okay. So I think guys, this is helpful. I showed you the entire like process how we can implement RAG. So in the next video, we'll be creating some LLM powered application with the help of this Vertex AI platform. Thank you guys.